students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will learn the numerical problems on a half cell electrode potential of the cell using Nernst equation. So we will, before jumping to the problems, we will have a glance on the Nernst equation. What is it and how is it derived? So this allows actually at standard condition, when it is present, we can use E cell is equal to E cathode minus E anode and calculate the EMF. But when the conditions are not standard, in the non-standard conditions, we have to use Nernst equation. So this is given by a scientist called Nernst. So the Nernst equation allows us to predict cell voltages or EMF, electromotive force, when the conditions are not standard. What are the standard conditions? At standard temperature, pressure, and standard temperature and pressure. So whenever there is it is not standard like 25 degrees centigrade or 1 atmospheric pressure, it is nothing but it is not standard. Whenever it is not at that particular conditions, it is not standard. So it is given by a formula like E cell is equal to E naught cell minus RT by NF. What is this R? R is the gas constant, universal gas constant, which is the constant value. T is the temperature, N is the number of electrons that are involved in the reaction or the electrode process, F is the Faraday. So Faraday, that is the charge carried by 1 mole of electrons in that particular reaction. So ln activity of products by activity of reactants. So whenever there is a reaction that is going on in any electrochemical cell, so the product's concentration or the activity divided by the activity of reactants will give the concentration or the coefficient. This is also called as a coefficient. It is because it is like largely used in the calculation. So there are like this activity is nothing but the concentration. So in dilute concentrations of solutions, we define it as molar concentration. In dilute solutions, we call it as molar concentrations. So whenever we find molarity solutions, we have to just use this formula in the activity wherein the concentration is defined. So the voltage difference between electrodes of an electrochemical cell is nothing but the cell voltage or E cell or E. So that is nothing but electromotive force. Electromotive force, EMF. So at standard conditions, it is E naught cell and E naught. So this is nothing but at standard conditions. And for any spontaneous reaction, this also indicates the spontaneity of reaction. So any spontaneous reaction will have a positive value for both E and E naught. For both E and E naught, the charge will be or the value that we obtain for the electrode potential is always positive. So there are different various modes, like we can use this Nernst equation. So for any single electrode reduction reaction, for example, this is the ions taking up electrons and forming metal. So this is the reaction. For example, this is the reaction. So what is the product here? The M is the product here. So product by reactants. So in this particular reaction, whenever there is reaction given, the products and the reactants are substituted accordingly. So when E and the concentration of M or the metal is unity, when they are pure solids and they are taken as unity or 1, then it becomes 1 by Mn plus. This is the reactant again. This is the reactant and the product is becoming 1 because the concentration of that particular product is 1. So at 25 degrees, what happens? 25 degrees is nothing but in kelvins, 25 plus 273 Kelvin, that is nothing but 298 Kelvin. After substitution in the reaction, this term, we get E is equal to E naught minus 0.059 by N is nothing but the number of electrons log 1 by Mn plus. So this is the reaction for Nernst equation that we use for the single electrode potential at 25 degrees centigrade. Whenever they are giving 25 degrees centigrade in the question, we can even straight away go to this formula and use it for the electrode potential calculation. So let us go to the examples. The first one, calculate the potential of hydrogen electrode in contact with solution whose pH is 10. So now here we have to understand what formula to be used, how we have to use the formula. So now, for example, this is given in pH, only pH is given here. It means the concentration is given, I mean the H plus ions. What is pH? Negative logarithm of H plus ion concentration. So that is nothing but the concentration of product or the reactant is given. So for any hydrogen electrode, when they gave hydrogen electrode, we immediately have to write down the equation for hydrogen electrode. That is the H plus ions. So H plus ions are always present. So that takes up the electrons and forms hydrogen gas. So this hydrogen gas is evolving. So applying Nernst equation. Why we are taking Nernst equation only? Because pH is given. So negative logarithm of H plus ions. H plus ions is nothing but pH. So we have to take this into consideration. So E naught is equal to E naught cell minus 0.0591 volt by N into log activity of products by activity of reactants. So whenever it is like given at 25 degrees, whenever there is no mention, it means at 25 degrees centigrade. So when for 25 degrees centigrade, the equation becomes like this, like E naught, we are replacing that, like the reaction H plus to half hydrogen gas. So the reaction is replaced, and same here E naught H plus to half hydrogen. So here we are substituting the H plus ions in the product or the reactants, because the reactant is H plus ion here. So the pH is nothing but the product concentration of H plus ions. So therefore we are substituting H plus ions here. And going to the next step, like what is the potential, standard potential for hydrogen? Standard electrode potential for hydrogen is 0. So we are substituting 0 here, minus 0.0591 by 1 into Y1. Here only 1 electron is used. So 1 into log 1 by 10 power minus 10. Why 10 power minus 10? Because pH 10 is nothing but H plus ions concentration, that is 10 power minus 10 molarity. When we express in concentrations, it is 10 power minus 10 mole. So upon calculation, we get minus 0.591 volt. So this is how we have to calculate the electrode potential whenever the pH is given in the question. So next, going to the next one, a zinc rod is kept in zinc sulfate. So we have zinc sulfate and zinc rod is kept. Zinc rod is kept in the zinc sulfate solution of what? 0.02 molar zinc sulfate at 25 degrees centigrade. So 25 degrees centigrade, and if Zn2 plus ions, if this ions from the Zn2 plus ions are converting to Zn, the potential is given as minus 0.76 volt, and Zn zinc sulfate will undergo 90% dissociation. What they are saying? They are saying they have given the percentage of dissociation. 90% dissociation will take place. So now calculate the potential of this electrode at this temperature. What is the temperature? 25 degrees centigrade, and they gave the dissociation percentage. So now we take the formula. Nernst equation, E naught is equal to E naught cell minus 2.303 RT by NF into log activity of products by activity of reactants. So with this, we will we have to also write the equation, like Zn2 plus ions from the aqueous solution is converting to Zn. So how many electrons are involved? 2 electrons are involved. So now E is equal to E naught minus 2.303 RT by NF log 1 by activity of Zn2 plus ions. Why Zn2 plus ions? This is the reactant. Here it is solid. For solid, it is 1. So we are taking 1 here. So how is this activity calculated? Taking into consideration of molarity. Molar concentration into dissociation fraction will give the activity of that particular metal ions. So 0.02 molar into 90 by 100. It is like it is given in the percentage. So we are converting into fraction. Like 90 by 100 is giving rise to 0.018 mole. So now the concentration is 0.018 mole. and R value is fixed like 8.314 joule per Kelvin per mole, and F is 96500 coulombs, and T is the 25 degrees centigrade that we have to convert to Kelvin, and N is 2 because 2 electrons are involved in the reaction. So upon substitution, we get, like, we are taking that concentration here 1 by 0.018, and all other, like this E0 cell is substituted here, which is given in the equation and in question. Minus 0.76 volt is substituted here, minus 2.303, then 8.314, the R value, then T value in Kelvin, 298 Kelvin, by 2, N is the 2 electrons are involved, and F is 96500 coulombs. So this is how we substitute the values in it, and upon calculation we get plus 0.811 volt. So this from this we understand that the reaction is spontaneous because the value is positive. So next, coming to the next one, calculate the EMF of the cell in which following reaction takes place. So what is the reaction that is going on here? Nickel and silver electrodes. So nickel silver cell. Here nickel is solid, that is dipped in silver ions. So silver ions having a molarity of 0.002 molar, and that is converting to nickel plus 2 ions. So oxidation is taking place in the nickel and the reduction is taking place for the silver ions. So silver is depositing. So they have also given the E cell, that is 1.05 volt. So what is happening here? This is oxidation for the nickel. This is the reduction reaction that is happening for the silver ions. So now we have to calculate about the EMF. So for calculating the EMF, this is the concentrations we have to take into consideration. Why? Because they have clearly given the concentration of the ions that are present in the cell. So now the silver ions and the nickel ion concentrations are given. Straight away we have to move to this formula, and because there is no mention about the temperature, we have to consider 25 degrees centigrade. 25 degrees centigrade. So 25 plus 273 is nothing but 298 Kelvin. So upon substitution in that equation, we get 0.0591 by N. N is the number of electrons that are involved. So here 2 electrons are involved. So it is 2, and the potential E0 cell is given like plus 1.05 volt, and that is also substituted here. And the concentrations are substituted here. Nickel ion, this is product, and this is reactant. 0.160 divided by 0.002 taken square. Why? Because taken square, here we have 2 Ag. Here we have 2 Ag. Here also the 2 Ag2 plus are reacting. So therefore we are squaring it. And now upon calculation, we get 1.05 volt minus 0.0591 by 2, and 4 into 10 power 4. So upon recalculation, we get a value of plus 0.91 volt. So again, this cell is also spontaneous. This cell can work spontaneously because the E0 value is positive. So next is to calculate the EMF of the cell. What is the cell here? Cadmium and copper, like cadmium sulfate and copper sulfate. Cadmium rod is dipped in cadmium sulfate. Copper rod is dipped in copper sulfate. So cadmium is cadmium sulfate having a molarity of 0.01 molar. And copper sulfate is having a molarity of 0.5 molar. And they have also given E cell value 0.38 volt. So now we require, what is that? This is the cell notation. So this is the cell notation. Cadmium to cadmium sulfate. This is a salt bridge, and this is the change in the stage. And copper sulfate to copper. The product is cadmium sulfate. in the one cell, and the reactant is copper sulfate here from the other cell. So N is 2 because 2 electrons are involved. So that is why N is taken as 2. So SO2, SO4, 2 minus in both the cases, anions are sulfates, and we use this formula where E naught is equal to E naught cell minus 2.303 RT by NF into log activity of products by activity of reactant. So what is the product here? Cadmium sulfate and copper sulfate. Reactant is copper sulfate. So same thing is substituted here, cadmium sulfate and copper sulfate. So what is the cadmium sulfate molarity? 0.01 molar. So cadmium sulfate and copper sulfate is 0.05 molar. So the same concentration is substituted, and N is substituted with 2 because 2 electrons are involved in this reaction, and this is the standard E cell value that is given in the question plus 0.38 volt. That is substituted here. So upon calculation, we get a value of plus 0.429 volts. So this cell is also spontaneous, and the reaction is also feasible. So next one is what is the EMF of the following cell at 25 degrees centigrade? So they have mentioned 25 degrees centigrade, and the zinc rod is dipped in zinc ion solution, and silver in the silver solution. So these two are combined together, and what is given again? E naught cell is plus 1.56 volt. So this equation can be used wherein concentrations are given, because two concentrations are given. Zinc is 0.01 molar and silver is 0.1 molar. So activity is taken, and in the present case, what is happening? Anode oxidation is taking place at zinc, that is zinc zero state, from zero state it is converting to plus 2, and at cathode Ag plus ions are converting to Ag. So like the net reaction will be Zn plus 2Ag2 plus will give Zn plus 2 and 2Ag. So upon calculation, like we have to substitute these values of concentration. Zn is 0.01 molar. So the product is zinc plus 2 ions. So and the reactant is silver ions. So we substitute these concentrations in the activity or the concentration column, because they have already given 25 degrees centigrade. We can use this formula like 0.0591 by 2, because 2 electrons are involved, like 2 electrons are involved here. So therefore N is equal to 2. N is equal to 2. And upon recalculation, we substitute this E cell value also, like plus 1.56, that is given in the question again. So whenever we find two concentrations that are given, we can happily go with the activity formula. So substituting those and the E cell and 0.0591, because 25 degrees centigrade, N value is 2. So it is log 1 becoming log 1, 1.56 volt minus 0.0591 by 2 into log 1, that will give 1.56 volt. So it is positive. So spontaneous, and the reaction is again feasible. So the next one is the voltaic cell. Here they have given two half cells. Half cells are given, like magnesium to magnesium 2 plus half cell, and tin to tin 2 plus half cell at 25 degrees centigrade. So temperature is 25 degrees centigrade. The initial concentration of Sn2 plus ions and magnesium 2 plus ions are 1.80 and 0.250 mole. So this is they have already given, so we have to calculate the cell potential. So what is really happening here? From this half cell we have to understand, like magnesium is converting to Mg2 plus. So that is like oxidation is taking place, and Sn is converting to Sn2 plus, but these two electrons are taken up by the tin plus 2 ions and form tin. So here reduction takes place. So the overall reaction will be magnesium plus Sn2 plus ions, magnesium 2 plus Sn. So that will become the net reaction. So from the E cell, we have to first calculate the E cell, because nowhere like E naught cell is given. So therefore, we have to calculate that E naught cell. So for that, we should take the consideration of E cathode minus E anode. This is cathode minus, that is plus 2.37 minus 0.14, which is 2.23 volt. So the EMF, after calculating EMF at standard condition like E cell naught, we will substitute the values. So this is the standard cell potential, which is when the concentrations are 1 molar. So when the concentration is 1 molar, this is the cell potential. However, we have tin 2 plus having a concentration of 1.80 and magnesium 2 plus having concentration of 0.25 molar. Therefore, we have to use Nernst equation for complete calculation of a cell potential. Therefore, we have to use the Nernst equation in calculating the cell potential. So here we will substitute like 2.23. This will be taken into E naught cell value. So 2.23 minus 0.0257 by 2 into ln 0.25 by 1.80. So this is product again, product and reactant. How did we get this? Like this is 0.25 is magnesium ions, and this is the magnesium ions. This is product, this is reactant. So from the net reaction, we have to consider the product and reactant concentrations and substitute in the formula, and we get 2.26 volt. This is the cell potential for that particular cell at the initial stage. So next is to calculate the EMF of the cell, wherein nickel and gold cells are kept together, electrodes are kept together, combination. So nickel is converting to nickel plus 2 ion with a molarity of solutions having 1 molar, and aurum or the gold, the plus 3 ions are converting to gold, which is having a molarity of 0.1 molar. So at a temperature of 298 Kelvin, it is nothing but 25 degrees centigrade. In Kelvin, it is 298. And given that electrode potentials also given, like nickel to nickel, nickel plus 2 to nickel is minus 0.25, and aurum like gold 3 plus 2 gold, it is 1.50 volt. So this is the overall reaction, like nickel plus Au3 plus gives rise to nickel 2 plus and gold. So here what is happening, nickel is going to oxidize, like oxidation is taking place at nickel and reduction is taking place at the gold electrode. So now we will be taking the product. This is the product and this is the reactant, and substitute in this equation activity of products by activity of reactants. That is nothing but E naught is equal to E naught cell minus 0.059 by N into log activity of products, that is nothing but the nickel concentration by gold ion concentration. So now we have to also understand that E naught cell is not given. So E naught cell not given. So now calculate that also, like 1.50 minus minus of minus 0.25. Why? Because of anode and cathode, like we are what is happening here, the nickel is oxidizing. Nickel is oxidizing, anode oxidizing, so anode, and this is cathode. E nickel 2 plus 2 nickel is anode. If we see here Ni2, Na plus 2, so oxidation is taking place anode, and gold 3 plus 2 gold cathode. So we know that cathode minus anode, E cell is equal to E cathode minus E anode. So we have to substitute those, like what is the E cathode here? Cathode is gold. So 1.50 minus of minus 0.25 volt. Like that, we have to calculate the E naught cell, and also calculate the 0.059 divided by n is taken as 6 because of two electrons that are involved, 3 plus 2, so 6 electrons, 3 into 2, the 6 electrons are involved, into log, this is the concentration they have already given. What is the nickel concentration? 1 molar, and this 3 is because 3 moles of nickel is used, so 3 cubic, it is again cubed, and 0.2 and squared because 2 are involved here. So therefore, we use this equation. We have completely substituted all the terms or entities present. So upon calculation, we have to get like this is becoming 100 and 1.150 or 1.50 minus 0.025 and 6 electrons, and this is becoming 100. So upon recalculation, we get plus 1.73 volt, plus 1.73 volt. This is again positive. So the cell is having spontaneous reaction, and the reaction is feasible. Feasible means it will happen. Reaction is feasible. So this is how we have to calculate whenever they are not giving E naught cell value. Like if at all we have the single electrode potentials, we have to substitute the same thing like EMF formula and use it here in the E naught cell. And also the calculation of electrons is also very important. Like we have to first write the equation. If required, we can also write the half cell reactions and then go for the net reaction and substitute accordingly the number of electrons and the terms that are how many moles of each metal ions are used. So the next one is the represent the cell in which the following reaction takes place, like magnesium and silver cell. So in this, what is happening? Magnesium oxidation is happening. Magnesium oxidation because increase in the oxidation state, and silver reduction, Ag reduction is happening. And they have also given the molarity of solution for the silver ions and the magnesium ions. The silver is 0.0001 molar and magnesium is 0.130 molar. Now calculate the E cell, and E naught cell is given. So E naught cell is also given here. So now we write this. So Mg to Mg2 plus is 0.130 mole and Ag plus 2, Ag is 0.0001 molar Ag plus ions. So this is the cell reaction that is going on. This is the salt bridge. It indicates there is separation of cell electrodes with the salt bridge, and there is a change in the state, physical state. Magnesium solid is converting the aqueous. So there is a change in the state and salt bridge. So this is the cell. So we have represented the cell now, and we have to calculate the E cell using Nernst equation. So what is here? The concentration of magnesium and concentration of silver ions are taken into consideration. E naught is equal to E naught cell minus RT by 2F into Y. We are taking 2 because N is equal to 2 ln magnesium ions concentration by silver ion concentration. So whenever we are writing this, we have to be very careful. Like we have to check the equation. So this is the product. This is the product. So activity of product is taken here, and this is the reactant. This is the reactant. Activity of reactants is taken in the denominator. So upon substitution, we get 3 minus 17 minus 0.21, and the E cell E naught value is plus 2.96 volt. Plus 2.96 volt. So the reaction is spontaneous again. And it is also feasible because it is greater than 1. Next one is an electrochemical is present with 2 half cell reactions, that is constructed based on 2 half cell reactions. So what are they? Oxidation reaction is with tin. The tin electrode is undergoing oxidation, and plus 2 ion, it is from 0 state, it is going to plus 2, and with an aqueous solution having concentration of 2 molar. and reduction is happening at chloride that is with 0.500 atmosphere, that is it because of gas. So the gas is present in atmospheres and two electrons are involved, and then chloride is forming with an concentration of 2 molar. Now, if the standard potential of this reaction is given as E naught is plus 1.09 volt. So E naught cell is 1.09 volt. Calculate the cell potential under the given cell conditions. So these are the cell conditions they have given. Now we have to calculate the cell potential. So the reaction is, the equation is E cell is equal to E naught cell minus 0.0592 by N into log Q. Q is coefficient. So here Q is nothing but the reactant by product. So product by reactant. So what is the product and what is the reactant here? If we see this reaction, 2 electrons and 2 electrons get cancelled. So this is the product, Sn2 plus ions, and 2 ClO2 minus are the products, and the reactant is ClO2 is the reactant. So similarly it is substituted in the Q, wherein it is the nothing but the activity of products by activity of reactant. So that is becoming, this is taken like concentration is considered. Concentration of Sn2 plus ions is 2 and concentration of ClO2 minus is 2 molar and squared because it is having 2 here. So the divided by 0.5 taken square because here 0.5 is given the concentration of the activity and 2 moles are used, so square. So overall we are getting Q value of 32. Q value is 32. So now substitute this Q value in the above equation. So the cell value, E naught cell is given plus 1.09 volt minus 0.059 by 2 because 2 electrons are involved in both the reactions into log 32. Log 32 wherein Q is taken. So we get a value of plus 1.05 volt plus 1.05 volt after calculation. So this is again spontaneous reaction and feasible. So whenever there is positive sign, it is spontaneous and feasible reaction. Next is write the Nernst equation and EMF of the cells at 298 Kelvin, that is nothing but 25 degrees centigrade standard condition, and it is having the bromide electrode, bromine bromide electrode and the hydrogen gas electrode. Given that E naught half bromide is plus 1.08 volt. So what is the cell reaction here? The bromide is converting to bromine. Bromide is converting to bromine because of hydrogen gas electrode. It is having H plus ions. So bromine plus H2 and number of electrons involved are 2. Therefore, N is equal to 2. So E cell is equal to E naught minus 0.0591 by 2. N is equal to 2 and log 1 by bromide concentration and H plus ion concentration. Why? Because this is product again. Product. So whenever there is Br2 and H2, it means it is complete and it is positive. Unity, taken as unity. In the ionic form, becoming the reactants and the concentration is taken into consideration. So what are these concentrations? Like 0.01 for the bromide ions, it is 0.01, and for the hydrogen plus ions, 0.03 molar. So upon and also they have not mentioned the E naught cell value. E naught cell value is not mentioned. So we have to take into consideration like this is the cathode. Cathode is 0 because of hydrogen standard hydrogen cell. So it is 0 minus 1.08 minus of 0.0591 by 2. So 2 is the number of electrons. So we have to calculate it. It is becoming minus 1.08. And after recalculation we get 1.11 into 10 power 7 and it is minus 1.08 minus 0.02808. So it is minus again. So 1.288 volt. It is negative. It is non-spontaneous and reaction is not feasible. Reaction is not feasible because it is having the negative sign for the E cell. So thus oxidation will occur at the hydrogen electrode and reduction will take place at the bromine electrode. So therefore oxidation will take place at the hydrogen electrode and reduction at the bromine electrode. If we see this cell reaction, we will know that anywhere there is a negative sign, it means the reaction is not feasible. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.